Okay, guys, how you doing today? So we're going to talk about writing products in a chemical equation. Here we go. So first we're going to start off with the basics. Here we have two examples. And notice that these are ionic compounds, meaning we have a metal with a nonmetal. Metals are always first, nonmetals are always second, with another metal and another nonmetal. So you may recognize these both as double replacement reactions. Again, metal, nonmetal, metal, nonmetal. So because it's a double, what's going to happen is the metal of the first one is going to join with the nonmetal of the second one. So first, all you have to do is take that first metal, sodium, and put it next to the nonmetal of the second one, NaO. So just start there. Plus, we're going to take the metal of the second one, the potassium, and join it with the nonmetal of the first one, the chlorine. All right, so that's your first step. We have to make sure that we have metal, nonmetal, metal, nonmetal. If for some reason you put two metals together or you put two nonmetals together, you did it wrong. It needs to be metal, nonmetal. All right, so the second step now is to take the charges and crisscross them, because we have to figure out what the ratio of sodiums to oxygens are going to be and the ratio of potassiums to chlorides. So you do that by crisscrossing the charges. So sodiums have a charge of +1 because it's in group 1. Oxygen has a charge of -2 because it's in group 2. Crisscross these numbers. This is the crisscross trick. Just put the 2 there. Put the 1 there, but we don't write ones. Okay, we'll do the same thing over here. Potassium's +1, chlorine's -1. Crisscross, but because they're both the same number, they cancel out. Okay, we're going to want to get rid of these charges after we're done crisscrossing them, because that's what proper chemists would do. You don't want to keep the charge of the ions on top of here once you crisscross them, because now they're joined together. So there you go. That is the formula, Na2O plus KCl. Okay, but now we have to balance as always. We have 2 sodiums, so we need a 2 over here. That gives us 2 chlorines, so we need a 2 over here. And that gives us 2 potassiums, 1 O, 1 O. There we go. There is our balanced equation, and we formed 2 products from these reactants. Remember, reactants are on the left, products are on the right. Let's try this one. Again, metal, nonmetal, metal, nonmetal. So take the metal of the first one, the magnesium, join it with the nonmetal of the second one, the bromine. Okay, don't worry about numbers yet. And let's take the metal from the second one, the aluminum, and join it with the nonmetal of the first one, which is the nitrogen. Okay, that's your first step. Just get them with the right partners. Again, double check that you don't have 2 metals together or 2 nonmetals together. You can't do that. It's got to be metal, nonmetal, metal, nonmetal. All right, again, this is a double replacement, just like the first one. So now we have to do the charges. Magnesium's in group 2, so it's a +2. Bromine's -1 because it's in group 17. Crisscross. This 2 will come outside of the bromine. The 1 will go by the magnesium, but we don't write that. Let's get rid of these numbers. We don't want them anymore. Okay, let's do the charges for the aluminum. Aluminum is +3. Nitrogen is in -3. It's in group 15. Crisscross, you're going to get 3 and 3, but because they're the same, they're just going to cancel out. Remember, these are just ratios. So we're just going to get rid of them. And our formula is ALN. Okay, so now we have the balance. So let's check it out. We have a bromine, we have a 2-3 situation with the bromines. So you know what to do with 2-3 situations. We got to go 3-2 because we want to get those bromines to 6. Let's see what else. So that gives us 2 aluminums. So we need 2 aluminums over here. We have 1 nitrogen. Oh, no, with 2 nitrogens. 2. There we go. That 2 goes to the nitrogen also. 2 nitrogens and 3 magnesiums on the left and 3 magnesiums on the right. We're done. There's our balanced equation. We wrote the products. This is the most basic of them all. Let's try something a little more challenging. So here we have some polyatomic ions. Notice the phosphate, the PO4, we have an NO3, we have a nitrate here. Okay, we're sticking with your basic metals, no transition metals yet. So we're just going to do the same thing. The polyatomics don't change anything. Just because there's some extra atoms in here, don't let that mess you up. Just treat it as one whole thing. This NO3 is going to stick together. This PO4 is going to stick together. All right, so let's take the metal, the first one, the calcium, and we're going to join it with the non-metal portion. Those polyatomics act as non-metals because they're negative ions. So we're going to put the NO3 right next to it. Let's put parentheses around it to keep track of it. Okay, and now let's do the metal of the second one, the sodium. And let's join it with the non-metal PO4 of the first one. So I'm going to put parentheses around this also. Okay, so now we have to do our charges. The calcium is a +2, nitrate is -1, crisscross. This 2 is going to go on the outside of the parentheses. Don't put it on the inside or multiply by 3 or anything like that. This 1 is going to go here, but we don't write 1s. Okay, get rid of the charges. We don't need those anymore. And if you can do this in your head, do it in your head. You don't need to write these charges up at the top every time if you can just do it in your head. And let's go over here. Sodium is a +1, phosphates -3. Okay, you can get the charges of these polyatomics on your formula sheet. Crisscross. This 3 is going to go here, outside the sodium. The 1's going to go on the outside of the parentheses here, but we don't write 1s. Get rid of these up here. There you go. There is our equation. So now all we have to do is balance. Let's see. If you don't know where to start at the beginning. We have 3 calciums on the left, so we're going to need 3 of them over here. All right, so then what happens? So now we have 6 nitrates. 3 times 2 gives us 6 of these nitrates. So we need a 6 here to give us the 6 nitrates. And then now we have 6 sodiums. We already have 3 from here, so we're just going to put a 2 there. Now we have 6 sodiums. And then now this 2 distributes to the phosphate. We have 2 PO4s, and we have 2 PO4s. We're done. There's our balanced equation. We wrote products. We're amazing. Let's try another one. Lithium sulfate, potassium phosphate. Do it again. Metal, the first one, lithium. Non-metal, the second one, PO4. Keep the polyatomics together. Don't mess with them. Don't mess with the numbers. Keep that 4 with the O. Let's see. This potassium, this K, metal is going to go with the polyatomic, so it's going to be KSO4. That's a 4. Okay, let's do our charges. Lithium is +1, phosphates -3, crisscross. This 3 is going to go over here. This 1's going to go on the outside here, but we don't write 1s. Get rid of this. We have to look like real chemists. Got to do this right. Let's go to the potassium, +1. Sulfate, -2. Crisscross. This 2 is going to go here. This 1's going to go out here. We don't write 1s. Get rid of this. Okay, there we go. Balance. Let's balance these guys out. Where are we going to start? I don't know. I'll start at the beginning. We have 2 lithiums, 3 lithiums. So we have a 3-2 situation. So we got to make them 6 by doing a 2 and a 3. So what happens here? That gives us 3 sulfates. Okay, so we need 3 sulfates over here. So we got to put a 3 here. That gives 6 potassiums. So we got to put a 2 here to get 6 potassiums. And that gives us 2 phosphates and our 2 phosphates. Bada bing, bada boom. We're done. Polyatomics. We wrote products. We balanced. Let's try another one. Now let's do some examples with transition metals. These are probably the hardest ones to do because you have to figure out the charges on transition metals. Remember, it's not +1, +2, +3 based on the group numbers. These are the D block elements and the charges vary. So it just depends on what they're hooked up with over here. That's how we'll figure out the charges. All right, but let's just start off by doing what we've been doing. Let's first join these guys together. So the iron, this metal, is going to go with the non-metal so the iron is going to go with the oxygen. Just write in your elements first. Partner them up. This zirconium, Zr, is going to go with the Cl. Okay, that's the first step. We have them paired up properly. All right, so now we know the charges of these nonmetals. -2, -1. We always know the charges of our nonmetals because those do not ever change. But we don't know this charge on this iron, so we have to figure it out by going over here. What is the charge of the iron here? Well, we have to do this little game. We have one iron, we have two chlorines, they're each -1, two chlorines, right? So -1 and -1 is -2, so this has to be a +2 because all these guys have to add up to 0. +2 -1 -1 is 0. So if the iron's a +2 on this side, it has to be a +2 on this side. It won't change how many electrons it has. It's just going to join with a different atom. So crisscross, the 2's, but they're both 2's, so we just get rid of them. They cancel out. We don't have to put little 2's on the bottom. And don't put little 2's on the bottom because, remember, these are always the lowest whole number ratios. And if you put little 2's down here, it's just going to screw up your balancing, and it's not going to work out right. All right, let's figure out the charge on this zirconium. Let's go over here. This time we have 2 zirconiums and 1 oxygen. Oxygens are -2. So what do each of these zirconiums have to be for this whole thing to add up to 0? Hopefully you said +1 each, because 1 + 1 -2 is 0. So this zirconium's a +2 over here. I'm sorry, this zirconium's a +1. So it's going to be a +1 over here. And again, these numbers are the same, so all we have to do is get rid of them. They just end up canceling out. Don't put the ones on the bottom. No one does that. All right, there we go. This is our equation. Let's balance. We have 2 chlorines here, so we need 2 here, 2 zirconiums. Good. 1 iron, 1 oxygen, oxygen. We're done. This is our balanced equation. Sweet. All right, let's try another one with transition metals. This copper is going to go with the oxygen, metal with non-metal. This nickel is going to go with the phosphorus, metal, non-metal. That's where we're starting. Okay. If you want, put in your charges for your non-metals. You know what they are. Oxygens are -2. Phosphorus is -3. All right. Because copper and nickel are transition metals, so we have to play this game. We got to figure out what they are. So we have 3 coppers. We have 2 phosphoruses. These are each -3. This has to add up to 0. So we have -6 on this side. What do each of these coppers have to be? 2. They're each +2. 2 + 2 + 2 -3 -3 is 0. So this copper is a +2. Crisscross, but guess what? They're both the same again. So let's get rid of them. They cancel out if it's the same number. Let's figure out this nickel. We have 1 nickel. We have 1 oxygen. We know oxygen's a -2, so that nickel has to be a +2. Let's put it in up here, +2. Crisscross, here we go. This 2 is going to go out here. This 3 is going to go there. Get rid of the charges up here. And now we're going to balance. Let's see, what do we got going here? We have 3 nickels, so we need 3 nickels. That gives us 3 oxygens. So we need 3 oxygens, 3 coppers, 2 Ps, 2 Ps. We're balanced. We're done. There we go. We form some products. So what's happening here is our reactants, they're mixing together, they're breaking bonds and rearranging and forming new bonds. And we're going to form some products. Let's try the hardest of them all, which really isn't any harder than the other ones we've been doing. Now we have transition metals with polyatomics. If you can do this, you can do it all. All right, let's do it. Iron is going to go with the nitrate. Silver is going to go with the sulfate. Okay, that's where we start. Metal, nonmetal, metal, nonmetal. Let's do our charges. Well, let's do our nonmetal charges. Nitrates are -1. Look on your polyatomic sheet. Sulfates are -2. All right, so we have to figure out the iron and the silver, but we got to figure it out from the left side. We have 2 irons. We have 3 sulfates. These are each -2. So we have -6 here. So what do these each have to be? 3 plus 3 plus 3. That's +6 -6, 0. So this iron is going to be a +3. We're going to crisscross it. Put it on the outside of the parentheses. This one crisscrosses here. We don't need it. Good. Let's do the silver. We have 1 silver. We have 1 nitrate. Nitrates are -1. So this silver has to be +1. +1 over here. Crisscross. Let's put the 2 from the sulfate over here. That 1 goes there. We don't write 1s. Get rid of all this other stuff up top. We want to look professional. Professional chemists would never leave these things up there. Most professional chemists would do this in their head, but you can too, especially when you practice more. All right, let's balance these guys out. Let's see what we have here. We have 3 nitrates, so we're going to need a 3 here for the silver. Oh, but wait a second. It looks like I have a 2 here, so I'm going to get rid of that 3. And we're going to have to make this a 6. Okay, because we have 6 nitrates. Now we have 6 silver, so we got to go here with the 3. That gives us 3 sulfates, 2 irons, 2 irons. We're done. There's our balanced equation. Iron sulfate. Technically, this is iron 3 sulfate. Silver 1 nitrate is going to make iron 3 nitrate and silver 1 sulfate. Double replacement reaction. All right, let's try the last example here for these transition polyatomic problems. All right, let's do it here. This gold, we have some gold here. This is our metal. It's going to go with the non-metal of the second one. So we have AuSO4 plus W is tungsten. And that's going to join up with this carbonate on the other side. The CO3 is acting as our nonmetal. Okay, we know the charge of our sulfate, -2. We know the charge of a carbonate, -2. We have to find the charges of the gold and the tungsten. So let's go over here. 2 golds, 1 carbonate. Carbonates are -2. So each of these golds are +1. So it's +1 over here. Crisscross. The 2 is going to go by the gold. The 1 is going to go here. We don't write 1s. Let's do the tungsten. We have 1 W. We have 2 SO4s. They're each -2. Oh, look at this, a +4. That's a weird number, but that's how tungsten is. So we're going to do that. We're going to crisscross. So we're going to get 4, 2. Okay. But you need to reduce this. If you can reduce these numbers, you reduce them down. So it's going to become 1, 2. So let's get rid of these here. Let's make that 1. They need to be reduced because, again, it's all about the ratios. 2 to 4 ratio is the same as 1 to 2, so we do the lowest whole number. So we're going to stick a 2 there. You have to reduce them down. Okay, so now we can balance. Let's see, what do we have going here? I have 2 sulfates, so I need 2 sulfates. That's going to give me 4 golds, so I need 4 golds over here. 2 carbonates, 1 tungsten, 1 tungsten. There we go. Oops, I forgot to get rid of these. Let's get rid of them so they look nice. There we go. There is our balanced equation. Nice job. And let's go on to the last part of this. This is our last example. We're going to look at combustion. Here, our first one's combustion. Here's a single replacement, and here's a combination. We're going to do the same rules as we've been doing. The ones we've done so far are all doubles, but the same process applies, except for combustion. Whenever you have CH compounds, these are hydrocarbons. These are things that burn. They burn, they need oxygen to burn, so hopefully you recognize this as combustion. What are the products for all combustion reactions? Hopefully you said CO2 and water. So these should be the easiest products to form because combustion's always CO2 and water. All right, let's balance. Balance your combustion reactions by looking at the carbons first. 1 carbon, 1 carbon. Good. Go in order. Hydrogen's next. 4 hydrogens there. So we need a 2 there to get that to 4. Do your oxygens last. We have 2 oxygens here. We have 2 oxygens here. So 2 plus 2 is 4. We have 4 total oxygens. So this has to be 4 total. There we go. We're done. We're balanced. All right. Let's look at a single. We're going to do the same thing. The metal of one is going to go with the non-metal of the other. So the Mg is going to go with the Cl. And now the sodium is the metal of one, goes with the non-metal of the other, but there is no non-metal, so sodium does not have a partner. That's why this is a single. So you're just going to leave the sodium alone. You don't have to put any numbers on it. Just leave it just as it is. But we do have to go here and crisscross these charges. Magnesium is a group 2 element, so it's +2. Chlorine's -1. Crisscross. Get rid of your charges. There we go. There we go. Balance. We need a 2 here for the chlorine, but now we have 2 sodium, so we can put a 2 in front of here. There we go. Balance. There's our single. Piece of cake. And the last one is the combination, which is probably the second easiest one next to combustion, because all you do for these combination reactions is put the elements together. All you do is have a metal and a non-metal, stick them together. That's what they're going to do. They're going to combine. That's why it's called combination. And now we have to crisscross the charges. Don't forget that. Aluminums are in group 13, so they're +3. Oxygens are -2. Crisscross. 2, 3. There we go. Get rid of our charges to make it look nice. And now we have to balance. We have a 3-2 situation with the O's, so let's go 2, 3. That gives us 4 aluminums. We're done. Writing products and chemical reactions. You can do it. Piece of cake. Be a chemist.